Fine, it started. Thank you.
So yesterday we have discussed about the 5G core side part. So today we are going to discuss about the radio side part. So both will together can create a 5G network. So let's start with the 5G RAN description. So here is a broad picture of 5G RAN subsystem. So this is a integrated RAN architecture. So in integrated RAN architecture, all the 5G subsystem like CU, DU are combined into a single unit. So here we have checked that there are two major parts are there. One is BVU, one is RU. So BVU is the combination of CU and DU connected through the mid hole, and RU is the front hole unit where you can connect your multiple RUs with the 5G BVU. So what actually these are? So first component is the BVU baseband unit. So BVU actually handles the signal processing, protocol stack, and communication with the 5G core network. So all the signal processing and all the this whatever signal is coming from the UA and where it has to move forward or where it has to send all the processing is done by the BVU. Then there is a RU unit, radio unit. So it manages radio frequency functions like sending and receiving wireless signals to and from UAs or user equipment you can say or normal mobile phones you can say. So any of the 5G enabled device can receive the signal from the RU and can send the signal to the RU. So this is the interface where this your UU interface is comes into the picture. What the communication is happening between the radio and the user equipment is happening through the RU. Then BBU is divided into two subparts in the 5G network subsystem. One is called as a CU and another is called as a DU. So DU is the distributed unit. So it is the physical unit of radio. So you can say process layer 1 and part of layer 2 functions. So basically it handles the PHY layer in the 5G subsystem. And then there is a central unit. So it handles all the layer 2 and layer 3 functionality of the 5G radio. So all protocol implementation or application type of implementation done in the centralized unit. And it is the responsible function for managing control plane data and user plane traffics. So here is the system description of integrated architecture where all your CU, DU, RU is combined into a single unit and become a integrated 5G RAN. So physical setup BBU and RU in a single unit. So whatever we had discussed in the previous slide like baseband unit and your radio frequencies signal units comes into a single unit is a integrated architecture. Both the baseband processing and RF functions are handled within the same hardware. So functionality remains the same, like all the parts will be within the single box. You can, if you have fitted it into a single box, it becomes a integrated 5G RAN. If you have deployed it differentially, means C you have deployed in the different server and then DU have deployed in the different server or RU you have deployed in the different server via the interface they require. That is a distributed architecture. So here in the 5G lab, we have supplied the integrated 5G RAN. So you all have seen as a single unit. So it is having the RU also. It is having the CUDA, all the functionality within the same hardware. Then connectivity. This integrated architecture require a single node connectivity. Means it can directly interface with the 5G core network. So via the Ethernet cable or via the fiber or via the any connectivity medium, it can connect to the 5G core network. So it uses the two type of protocol. One is NGC and one is NGU. So NGC is the control signaling message and NGU is the user plane data. So NG we are calling because it's a next generation radio. We named it as it. So this is the protocol. This is the interface name becomes the NGC and NGU for control plane and user plane data. Then this single unit having all the functionality of the 5G CU, DU, and RU, like all the functionality like PHY layer is there, MAC layer is there, RLC, PDCP, RRC, and all these type of protocols comes into a single hardware, become as a integrated architecture. The complete 5G NR stack is processed in the same hardware, physical hardware. So, what is the benefit of making a integrated subsystem? Like it reduces the hardware cost also. It reduces the communication delay also because all the processing is happening within the single system. So it reduces this network delays also. So how many interfaces this integrated hardware is having? This is basically it is having two types of interfaces. One is called as NG interface, another is called as XN interface. So NG is basically where this radio is going to communicate with the core network side. So this becomes the NG interface. So there it is going to use two type of interface. One is N2. N2 is basically to connect with the AMF, and then another one is N3, which is used to connect with the UPF. So where it will connect with the AMF, it will process all the control signaling over the N2 interface, and where it has to send the user traffic, then it will connect to the UPF via the N3 interface, and then it will process all the user real-time data into the N3 interface. Then there is one another interface which is called as a action interface, which basically help us to connect the multiple G node B to each other. And what actually it does in the 5G subsystem, when you moves, so mobility comes into the picture, then we require a handover. Like from one G node to another G node, we are going to move. Then we need to shift the context of the users. So in that term, this action interface comes into the picture. So there are two types of handover in the 5G subsystem. One is called as N2 handover, and another one is called as action handover. N2 handover is basically what, when one G node we inform the core to do the handover, and core is going to transfer the context of the users to the another G node we is called as N2 handover. And when G node we integrated over the action interface, then they can do the handover, then notify to the core subsystem. So it helps us to maintain the mobility of the user equipments. So whenever user moves, it can get a seamless connectivity with the 5G networks. Then RAN subsystem description is there. The radio access network RAN is a part of telecom system that connects user devices. So without the RAN, the wireless device cannot connect over the 5G network. So RAN plays a crucial role in the 5G network subsystem. User equipment to the mobile core network over the air. It helps you to connect to the core network over the air, because this all UU interface, wireless interface is implemented in the radio access network, and it can connect over the wireless interface via the UU interface. Mobiles is or UE is able to connect with the 5G network system. It can become a part of 5G network, and it can reach the seamless functionality over the 5G. It handles the transmission, means whatever transmission is happening, whatever packet exchange is happening between the core network and the user equipment, and it process and manage of radio signals between UE and the core. So all type of processing is whatever is coming from the user side, whether it is user plane data or it is a signaling or control plane data. So it is managing and processing by the RAN subsystem. It enable all mobile services like voice, data, messaging. So once the user equipment is able to connect with the 5G network, then it is able to use the services whatever is allowed to the particular user. Like if voice services is allowed, it can use the IMS services. If data is allowed, it can use the DN services, data network services, or messaging. If it is implemented the messages, then it can use the messaging services also over the 5G network. So all these require a connectivity to connect with the core network. So RAN is providing that connectivity to the user equipments. Then RAN architecture in 5G. the 5G RAN is more flexible and distributed compared to previous generation. It consists of three main components, as already we discussed. Like it is having totally three components. One is centralized unit, one is distributed unit, one is RU unit. So there are different type of deployment architecture where it can be designed according to the need. Like if you are having a single block where you can use the integrated network because it will be the cost effective and it will reduce the signaling delay and network delays also. But wherever you have to deploy it at a large scale, then to manage it a cost effective, then you are going to use the centralized unit distributed radio unit. So you have to follow the distributed architecture to save cost and all these type of connectivity and seamless connectivity. So there you are going to use your centralized unit. You are going to deploy. Then one centralized unit can connect to the multiple distributed unit, and then you can deploy the radio units, and you can connect all these over the interface. Like CPRI is required to connect the RU to the DU, and then another fiber or backhaul or whatever is required for the connectivity of DU and CU. So one CU can handle multiple DU and multiple one DU can handle multiple RU. So that will be the benefit of distributed architecture in the large scale. And this is the broad overview of RAN architecture in the 5G subsystem. So how it can connect with each other, like all the components we have discussed. So how they are going to connect with each other. So one side there is a integrated RAN, first one where we have written only GNP, and another side there is a this distributed architecture where we have divided it into the CU and DU two subparts. So both G-Node can connect over the XN interface. So XN control protocol will be implemented there. And to connect with the core network, they are using NG interface. So N2 interface they are using, or N3 interface they are going to use to connect to the various core components like AMF or UTF. The next
No,
one,
one, Navjyoti. I request all of the institute members, all the students, if they are, please make it interactive. If you have any doubt, any query, any question, please ask so that this session seems like an interactive session. Thank you very much.
next generation RAN, we called it as a NG RAN. The RAN is responsible for wireless communication between the user equipment and the 5G core network. It includes the following element. So basically, what RAN is, it is a intermediate between the core network and the user equipment. Means it's a connectivity medium only. You can say it provides the connectivity like wherever you are going in your office architecture. Also, like if you have to become the part of your office network, you are connected your laptop or your PC through the Ethernet cable or Wi-Fi. So the Wi-Fi or Ethernet switch is the connectivity medium. Similarly, in the 5G subsystem, this RAN is the connectivity medium for the UE to core network. To use the services, whatever services is required to use, like voice data, messaging, and so many other services. Next generation node be the base station in 5G, which can be implemented as two type of architecture as we have discussed. Like here we have mentioned it as a monolithic G node B and disaggregated G node B. So monolithic is whatever it is a integrated architecture. Like in the 5G, we were having a in the 4G we were having a single system where all the protocol stack is within the same hardware. So similarly in the 5G also you can design a monolithic G node, or you can say it as a integrated G node B. All the function in the same hardware as we have seen in the previous slide. And disaggregated architecture of G node B also we have discussed, where we have split the main baseband unit into the two parts, one is central unit and distributed unit. So the benefit of splitting these two parts is flexibility and scalability. Like if I am I am expert in creating the control plane messaging, and I can process and manage all these things, so I can design the CU, and some other is expert in the layer 1 protocol, so he can design the DU. So by combining both of them over the standard ORAN protocol, open protocol or ORAN protocols, we can integrate both of them, and then it can give us flexibility to design similar parts, small parts. In the right side diagram, you can see that there are multiple DUs are connecting with a single CU. So it gives us the more other functionality like a vendor interoperability also. Like one person can do the particular work and another person can do the particular work, and over the standard protocol they can communicate with each other. So there are G-Node with CU centralized unit. So as we have discussed, centralized unit is handling higher layer functions like a layer 2 function and layer 3 function, where your this all RRC and all these messages are going to exchange between the UE and the radio network. So all handling of all these messages and application related data is handled by the centralized unit, and processing is done by the centralized unit, and then it is passing through the core network. Like whatever packet is required to send to the core network, what is packet is required to handle by the G-Node itself, and give it to response appropriately to the user requirements. So it manages the radio resource control and handle mobility, security, and QoS policies. So to create a specific type of resources, it all are managed by the CU. So it also handle the mobility of like whi- which users are connected or how these are connected, their context management, and all these type of things are done by the centralized unit. Also, it helps us in the QoS policies. Like to connect with a particular type of video, we need a QoS flow. For connecting with the data network, as yesterday we have seen that there is a QoS 5K value 9 is enforced, where this priority value is also there. So all these are managed by the CU. So CU will manage that this is a high priority packet or this is a lower priority packet. So according to that, it can allocate the resource to the user equipment or any other devices, whatever is connected to the 5G RAN subsystem. Then there is G-Node bit distributed unit. So it process all the lower layer function like PHY layer, MAC layer, and RLC layer. So all the physical layer type of function is processed by the D unit. So you can say all the layer one related packets are processed by the distributed unit. And then there are multiple interfaces which help us to connect the 5G RAN subsystem smaller parts, or it connect with the 5G core subsystem. Like NGC we have discussed, NGC is for a next generation control plane protocol. So for signaling message such as registration, authentication, or whatever type of packet. So as yesterday we have seen, there are NGP is the protocol, and NAS are the packet going through the core network from the G-Node view. So all these signaling messages are handled by the NGC protocol over the end-to-end interface. So all these messages are coming from the UE, where it is marked it as a these are the NAS messages. Then radio will send it to the core network over the NGP protocol. So in the WhatsApp, as we have seen yesterday, the NGP slash 5G NAS messages. Then there is a NG packet user plane traffic, where once the user is got authenticated or registered with the core network or radio network, then it become the part of the network. Then it process sending its data. Like if you are doing net surfing or data surfing, or you are using or causing your internet data. So all the data is going through the NGU, user plane traffic. So in this case, it is going to manage this GTPU interface. So it will process all the user plane related data, real time data over the GTPU protocol to the UPF. Then there is one more interface, F1 interface. As we have seen in the last slide, like in the second architecture, F1 is the protocol used to connect the DU and the CU. So F1 is the interface, and F1AP is the protocol to connect the CU and DU in the 5G core subsystems. Then there is one another interface, XN interface we have discussed like that it support us to do the smooth handovers and mobility management. So action interface is also divided into two smaller parts. One is control plane messages and one is user plane messages. So control plane messages where two nodes are talking to each other to do the handover of the user and do the transfer of the context from one GNode to another GNode. So all session related data is going to transfer over the control protocol. Then user plane data is going to transfer over the XMU interface.
Hello.
Yes, sir.
Sir, in the last diagram, there are more than one DUs in a single genome. Can you please go? Yes. So,
Yeah.
can, yeah.
So yeah, I can explain. Like in the 5G subsystem, we have divided it into three parts. One is CU, one is DU, and then one is RU for the radiating the frequency, right? So in the distributed architecture, one CU can handle multiple DUs. So different DU can connect to the single CU, and then multiple RU can connect to the single DU also. So like here, two DUs we have shown in the picture. Two we have connected with one single CU. Then again further you can connect multiple RU with one DU. So it is it is flexible and this scalable help us to scale the network.
Where is RU? Where does RU come in the picture in this architecture?
RU will come in the picture when user equipment has to connect to the radio, right? Then RU
So,
will comes into the RU will help us to do the this frequency radiation.
radiating and yes, for
Yeah,
transmission and reception. Also,
yeah,
there are more than one DUs connected to a CU. CU handles the functionality of higher layers, as in the next slide,
yeah.
and DU
Application
is
layer or this protocol layers.
so DU is like a number of devices that can be connected under a single EU, CU.
No, no, no. DO is not like DO is like a like you had divided your you have created three services, like right?
Yes.
So for one service you have connected created a single server called as a centralized unit, right?
Okay.
Then some protocol you have implemented in another two servers called as a DU. So where your RLC and all this functionality comes into the picture, like PHY layer and all these messages you are going to process, then it comes to the DU. Then multiple DU can connect with a single CU because CU is a powerful server centralized unit, so it can handle multiple DU connections. Like one DU is sending this message, another DU is sending this message, right? So it can process accordingly and response back.
Can you sir please explain again? I didn't got it.
Uh, like in our native environment, when we are doing load balancing, right?
Okay, sir.
So in the load balancing, what we are doing, we are creating a proxy. You can call
Yes.
it as a CU. You can call it as a CU. Then we
Okay.
are creating multiple server behind that, like one server, two server, three server, four server. For like a web application, I am going to create a this clustering. So four web servers I have deployed. So one request can be handled by one web server, another request can be handled by another web server, and third one can be handled by another web server, right? So
Okay.
these servers become the DU, right? So
Yes. Yes.
there's
Got it.
smaller work they can do, and over
Yeah.
the proxy can process all the messages coming from all these DUs, right? And can distribute it
Yes.
accordingly. So
Thank you so much.
this is the similar type of architecture only. Can I proceed further or any more
Sure, sir.
clarity required? So here we have discussed like last one interface is action interface, which helps us to do handover and mobility management, right? So in the mobility management, what user is doing, user is keep on moving. Like whenever we are having mobile type of device or user equipment, we are not the stationary type of devices. Like today one person is in X location, tomorrow it can be on Y location. So if we have created our network over a large scale, so it will move from the one G node to another G node or one RU to another RU. So in that case, we require the interfacing of this all the network equipment, all the radio related parts like all the Genode we are going to connect over for the handover protocols. So all action related protocol should be implemented there to do the smooth context transfer from the one Genode to another Genode. So user can experience a seamless connectivity. Then there are feature and functionality of the RAN subsystem. A 5G radio access network feature functionality like beamforming, massive MIMO, and network slicing, dynamic spectrum sharing, small cells, and the use of millimeter wave technology to deliver high-speed data, low latency connectivity by efficiently managing the radio signal between the user equipment and the 5G core network. So it is having multiple type of functionality. Like beamforming is done by the RO unit only. So RO unit handle all this functionality to do the beamforming, like which frequency is coming from backside and what are the instruction coming. According to that, it can beamform these frequencies. Then massive MIMO architecture is there, 2 by 2, 1 by 1, 4 by 4. So multiple type of massive MIMO architecture are there. Multiple input, multiple output, where user equipment can connect more than one radio channels. So all the massive MIMOs are there. Then it is going to handle network slicing also. As in the 5G subsystem, slicing is the new concept. So according to the need, we can create a particular type of network for the user equipment, so we can deliver it a seamless experience. So suppose like that, somebody don't require high speed data, but it require a number, lots of means it has to create a multiple sessions, or like some IoT sensors are there, so it has to send data every seconds, or it has to send a bulk data like 100 this you can say 100 sensor data it has to send. So 100 devices is going to connect to the single type of network. So where we are going to use the MMTC type of slice, so we are going to create the different type of network where user is required higher throughput, but over a single connection, like one device is going to connect and he is going to use 500 mbps data or 600 mbps data or more than that according to the need. So we are going to create therefore the user EMBB slice like enhanced multimedia broadband. So he required higher throughput, but latency and this number of devices are not matters. So different type of network can be created with the help of network slices. Then dynamic spectrum sharing. According to the need, this radio can be configured to create share the spectrum dynamically. Then small cells and use of millimeter wave. Like millimeter wave is designed for higher throughput data. So particularly for MBP slice, where a user need a GBps of data per second, like for 1 Gbps, 2 Gbps, 3 Gbps data it requires. So their millimeter wave comes into the picture because there the spectrum bandwidth is higher. So higher the spectrum bandwidth, it will give us a more throughput. So it can we can create a high speed data like we have discussed about the EMBB slice. Then low latency. So as yesterday we have discussed about the URLLC slice is there. So you need to create the network type of this slice number 2 URLLC. So you can deliver the latency and you can manage this connectivity and give a seamless experience to the users. Also, it can manage radio signals efficiently between the user devices and the 5G core network. So all the radio signaling processing is done by the 5G RAN. So it enabling application like augmented reality, AR is AR has already deployed in the 5G lab. So this AR VR technology are there for autonomous driving and high bandwidth streaming with improved coverage and capacity compared to the previous generations. So all these are the key features of 5G RAN subsystem which can be implemented and can provide the connectivity to the user equipment according to the need. So these are the listed features like massive MIMO is the feature in the 5G subsystem. So you can create a radio type of massive MIMO Then network slicing you can implement it for different type of users. Then small cells you can deploy. Then millimeter wave technology you can use. You can design a radio which can handle the millimeter wave, and you can use the higher spectrum and can give the more throughput data. Then DSS is the feature as we have discussed, dynamic spectrum sharing. And there is distributed architecture as we already spent the time on this to understand the DU and CU parts. So connectivity medium, how you are going to design your system. This is the ways of designing your system.
Nowadays, sir, there is a query from PEC, Punjab Engineering College. How will this
Mhm.
be helpful in research for a millimeter wave communication system?
How will this be helpful in research for a millimeter wave communication system? Sir, I don't know how to means I don't know about much about millimeter wave. So that you need to explore the things. These are the key features. So over there you need to do the experiment for that. So I am not expert in millimeter wave, so I can't comment on that. So how I can research on millimeter wave?
Hello, sir.
Yes,
Good
sir.
morning. It's
Good morning,
Dr.
sir.
Mandeep Singh from Punjab Engineering College. Can you please
Yes, sir.
explain about the massive MIMO technology in this system?
Massive MIMO technology, when you are going to use your system like you are having multiple transmission channel and multiple receiving channel. Like you are going to create your radio for 22 hour or 44 hour or 88 hour. So this,
Okay.
yeah. Then feature and functionality of the RAN subsystem. So as already we discussed, like radio signal transmission and reception from the user.
Navjyoti,
हाँ जी सर बताइए.
there is another query from Gautam sir regarding the SIM and eSIM.
UE side SIM and eSIM, and what kind of software you have to configure the eSIM in the phone. Additionally, how can communicate with Gnodo to be established using. So these two type of the profile mapping, like what you is doing, you is taking some values from the SIM to authenticate itself with the network. So first values are like PLMN values are there. Whether you are write it into a eSIM form and you are inserting a physical SIM. So these two different type of technology, how user can read this user related data. So first are the PLM values on the basis of which it is going to connect with the Gnode wheel. Like with Gnode wheel, it maps with the, so it will connect with the Gnode wheel according to that. So PLM value first it will match. So according to that, it will try to register with the same PLM radios. So whatever will be available over the frequency. Then there, when it is going to connect with the core network, it will use two three values from the same. Like MC value it will use, then K value is there, then OPC value is there, and then which method you are going to use for the authentication, like Milnes algorithm or Snow 3G or XOR algorithm. There are multiple methods. So based on that, it will use to create eSIM. There are multiple companies who is doing this eSIM profiling. So I can't say means how we can connect. So there are expert about that. So you need to talk to them how you can create eSIM. Physical SIM, there are SIM writers are available. So you already have got delivered in the lab. So there is a software. In that software, you can insert your values and can configure your SIM cards. Hello, Naveen sir.
Yes, Navjyoti, you can continue.
ठीक. So then there are feature and functionality of the RAN subsystem like radio signal transmission and reception. So all the transmission sending from the UE based on some values, it is going to connect. So all these are handled by the radio unit in the 5G network subsystem. Then resource allocation is done by the unit, like how many channels I need to allocate to this particular user, or how much can be the bandwidth allocated to this particular user. So what downloads throughput it can get and what upload throughput it can get. All resource management is done by the radio network subsystem instructed by the core. So then mobility management is it is doing, as already we had discussed, there are action interface which help us to manage the mobility between the multiple mobile equipment or multiple user equipments. So it helps us in the mobility management. Then their QS control is there. So different type of service is having a different type of QS control. Quality, this is quality of service, like which type of quality user has to get. If it is a mission critical service, so it has to get the more priority over the normal user. So according to that, it can manage the QS control. Then there are some specification of CUDU, RRU, 5G radio, some specification which technology it is going to use. Most widely, we are using N78 band in the 5G subsystem. So N78 band relies between the 3.3 gigahertz to 3.8 gigahertz. So 100 megahertz channel bandwidth you can allocate in this particular band, and then you can use integrated and distributed architecture according to the deployment. So N78 band, if you are going to use it, is a TDD band. So your this duplexing mode will be TDD. Then how many sectors are there in the radio you can plan. Then how many users can connect, like minimum 32 we are going to connect, or more users you are going to connect. So all these are the specification of this radio. Like then there is MIMO, which this is the specification of whatever is delivered in the labs. So in the lab, it is delivered like this 5G RAN, then N78 its port. It is an integrated radio access network, whatever it delivered to the labs. Then TDD it sports one sector radio it has. Then 32 user it can connect. Slash active can be 32 users. Then MIMO functionality is there. Minimum 2T2R is there. So as you have seen in the labs, there is a radio which is having four antennas, two for signaling, two for transmitting. So MIMO modes can be configured there. Here is configured as a SU MIMO. Then RF power we have configured as a 100 milliwatt. So it will radiate in a smaller area. So according to your hardware unit, you can control this RF powers. Then carrier aggregation, if it is implemented, then you can use the carrier aggregation. Number of CC in the lab is one only. So bandwidth is given up to 100 megahertz channel bandwidth we have allocated to the radio. So when we are going to configure this radio, we will show this part to you. Then SCS value is 30 kilohertz we are running as of now. So in the 5G subsystem, it can be 30, 60, 120. Then for the synchronization of time clock, we are using GPS, or you can use IEEE standard like PTP protocol, and all these are the mechanism. So this is the specification which protocols are used in the 5G radios. Then 200 MB throughput is shown, I think, and then the which interface it is having, like it is having 10G copper and 10G optical also. Number of layer, like DLUN, it is having 2 by 1, so two DL layer and one uplink layer is there. Then two type of COM is implemented in that radio, 256/64. Then user/TTI values are there. Then we comes to the implementation of 5G RAN. So server specification required for 5G RAN. To support the 5G RAN in a box system in the lab, the server must meet specific hardware and software requirement. The server will handle processing, networking and storage need of 5G RAN functions, baseband processing and potential integration with the 5G core network. Like it requires a particular hardware subsystem which is delivered to the labs. Then to connect with the core network, it requires the connectivity medium. So providing the connectivity medium over the interface is defined in the 3GPP specification. According to that, it can connect to the 5G core network or the N2 or N3 interface. Or if we have to connect the multiple G-node, then XN interface will comes into the picture. Then there is the explanation of hardware purpose for the lab. The purported hardware is a compact 5G RAN in a box, so we have delivered an integrated radio there. This is a single piece hardware solution designed for lab testing and small scale deployment. So it is not for the macro deployment; it is the small scale deployment. Like within the lab only, you can get the coverage. So you can define your functionality, and student can learn from that. This unit integrates radio access network and the baseband functionality into a single enclosure, simplifying setup and operation. It features an internal antenna system, like so all the antennas and RU units are built in the same hardware. So you just need to connect the antenna over that, reducing the need of external RF component while ensuring efficient signal transmissions. Then their key feature and capabilities. So this is all about the hardware deployed in the 5G lab. So first it is a integrated RAN design. So both all three units are designed into a single piece hardware. So all the hardware connector like radio unit is there. Then DU and CU part is convert this mounted into the single hardware. So it becomes a integrated RAN. So the benefit of this is there is no infrastructure complexity, like you have to deploy the single box only. When you are going to deploy the distributed architecture, then you require different type of subsystem, and then you need to integrate all them, and then infrastructure you need to create according to that. In this integrated RAN design, it eliminates the need for separate baseband processing unit, making it ideal for lab environment. So all these benefits we are getting with the integrated RAN design in the lab environment.
Hello.
Then,
Sir, is there any option that we can disintegrate this RAN design? Like you have
no, no,
provided the.
this particular hardware cannot be disintegrated. Then disintegrated architecture you need to design according to your need, means whatever
Okay,
will be
just
suitable.
deploy. If we need to deploy disintegrated, we have to deploy into a different machines. RU need to be deployed over different machine and DU on another one. Is it
Then
like
you need
that?
to deploy. Then you need to deploy three type of things. Like one is RU, then DU will comes into the picture, then CU will be the centralized unit. Then you need to deploy the whole architecture, and you need to do the proper connectivity. Like CU to DU, there is a fiber optical connectivity you can do, and then DU to RU, there is a CP connectivity you need to do. All these infrastructure you need to create according to that. But our hardware is integrated only. So
Okay. Thank you so much.
then internal antenna system, it is having internal antenna system, active antenna configuration, enhanced signal coverage and performance through beamforming and
Navjyoti,
yes sir, बताइए.
There is a
Hello.
question from Gopal, IIT Mandi.
हाँ.
What is CC?
CC is the carrier aggregation sir. ये तो हम बता चुके हैं. CC is the carrier aggregation.
CC in terms क्या है? 5G के terms में CC होता है.
नहीं नहीं, एक
मुझे नहीं-
हेलो. और कुछ पूछना नवीन सर. मैं CC कैरियर एग्रीगेशन है, उसको
हाँ,
कंपोनेंट
दो
कहने
चीजें
में.
हैं. वन इज दो चीजें हैं. वन इज CC एंड वन इज TTI.
वन इज CC एंड CC तो बता दे, जिस तरह उसका जो CC का फुल फॉर्म होता है वो कंपोनेंट कैरियर होता है. फॉर कैरियर एग्रीगेशन के लिए हम उसको यूज करते हैं.
एंड वन इज TTI.
वन इज TTI.
T is
TTI.
a time interval
Time.
है ना? हाँ,
Yeah,
transmission.
that is transmission time interval. Like when a packet start from the UA and it reaches to the radio network to the center. If it is a distributed architecture, then it will take more time because first it has to come to the RU, then it has to go to the DU, and then it has to go to the CU. So in the integrated, this TTI value will be lesser. This is transmission time interval, like how much time this transmission took.
Okay. Continue, sir.
Then we are having an internal antenna system. So active antenna configuration enhance signal coverage and performance through beamforming and optimized RF output. It support 2 to 2R MIMO, ensuring stable connectivity and efficient spectrum usage. Then internal antenna design reduces deployment challenges and eliminate external RF cabling. So like if you are going to deploy the distributed architecture, then you need this all RF cabling and all these type of works you have to do. In the integrated network, you don't have to do anything. You just put your hardware and just connect it with the network and with the core network, and it start working. Then this is frequency and bandwidth. So in the lab, 5G NR is operating on the NR band and 78, 3.3 to 3.8 gigahertz, a key mid-band frequency for the 5G network as commonly used. It support up to 100 megahertz bandwidth, allowing high data throughput in the lab simulation. Then connectivity and interface. So this hardware is having 10G Ethernet for high-speed backhaul and data transfer. Then it is having GPS sync IEEE 1588 version 2 support for accurate time synchronization. Then it is IP65 rated enclosure, ensuring protection against dust and moisture even in rugged conditions. Then performance and user capacity. So minimum 32 concurrent users supported, making it ideal for multi-user testing scenarios. Then downlink throughput of 200 plus Mbps, simulating real-world 5G performance. Then 4 user per TTA, optimizing scheduling and resource allocation. Then there is power and mechanical design is there. So it's a compact form factor. This is the specification is given. How much power it is taking: 60 watt, 48 watt input, and ensuring efficient energy consumption. Then we comes to the use cases. 5G network testing. So validation and performance under various conditions you can do. Then application development you can do over the 5G network. So there is deployed 5G core is already deployed and 5G RAN is deployed. So testing 5G enabled application in a controlled environment. Then interoperability testing you can do with that particular setup. So like if tomorrow comes the different vendor of Unode or different vendor of core is coming into the picture, so you can evaluate compatibility with different core network elements. Then you can do training and research. So for the students you can do live training and give them an hands-on experience. Research scholar working on the 5G technologies, so they can take the reference from here and can design their solution appropriately. Then provisioning of server for installation. The RAN in a box solution proposed for the lab is a fully integrated system that include pre-installed software of centralized unit, distributed unit, and radio unit within a single hardware package. Since this is a self-contained deployment, there is no need of an external server to install or run individual CUD functions separately. So it's a cost effective also. So as all the hardware is already provided in within same unit. Then OS and virtual software installation is done in the lab. Like we have created a VMware or KVM. The RAN in a box does not require an external OS or hypervisor installation as it comes with preloaded firmware and software optimized for the 5G RAN functionality. So no need for VMware, KVM and other virtualization platform as the system operates natively on its own embedded OS. So it is embedded solution, so it doesn't need any other type of OS required to install it. So then this is the configuration part of 5G core. To configure core element, we need to update the. There is we are having a single configuration file named it as a Coral placed in the ADC default directory. So these changes you have to do as per your deployment. Like if you are using test element, so there MCC and MNC value is like 00101. Then tracking area code you have to match with the radio access network and the core network. Then this, if you are deploying different type of slicing, then this SD value and SST value you need to define here. Which mode you want to run this core subsystem, like VNR you are going to run, or for 4G if you are going to run it as a voltage, or if you are going to run it as a integrated, both NSM mode. So you can configure according to that. Then there is a IP location. So all this is the configuration part. We will later it include in the next session when.
Hello.
Yes, sir.
So we have two physical machines over here, and can you please explain what all virtual machines are installed over there, and like we have IP addresses of the physical machines, like one of them is 5150 and another one is 51. So what all virtual machines are there, and what are the functionalities of those machines?
Naveen sir, can you comment on that?
Sir, can you repeat? You're talking about 50 plus 60 plus 50 and 60 plus 51. That is IDRAC IP only for the
Yes,
server.
ID
For
rack.
the,
Yes,
yeah, that is
there
for
are
the
two.
management only. But for that, whatever we have, I mean 5G core and other MEC and all, no, there is IP address different. I mean, it is implemented in the VM only.
Yeah, Sunil sir, I got that, but I just want to know that what all systems are deployed on these two servers, like on the upper machine and lower machine. You gave us the IP addresses for the NMS and everything, and what all systems are deployed and how, like just in case system has some issues, how can we redeploy that thing?
Sir, that credentials that we shared, still we can state, the first server is, I mean, 5G core and NMS, and down one, that MEC server only. So there are more like, what we say is there are MEC implementation for that devices also. That is, drone, like, drone is there. No? Drone we implemented out there. Drone camera actually that he started. Maybe we will do it today or tomorrow in your system. Okay, so IP addresses we shared with you, and we can, we can credentials we can share it again. I remember that I we
Implementation document has been shared already. If you don't have, we will share it again.
Okay, so another thing is like the regarding 5G, this radio unit. So we don't have any specification like what is the SAR and what is the power unit, like all the specification. We don't have anything about that radio unit.
Data sheet, I think, has provided to every institute.
No, I suppose we don't have that.
I will share it again, sir. Don't worry about that. If anything, you just give me a message. I will share it to you again. No issue.
Okay, okay, thank you so much, sir.
So we were talking about the configuration file. So this is the Coral configuration file. So above is the URL of that directory of that file, etc default, and then Coral is the file name. So here is the mobility section at the core side where you need to define all the values, whatever is to be said with the RAN and the core network. So like MNC MCC is required to connect with the core network with the radio access network, then tracking area code is required, then whatever slicing it supports. So all these values are required. So all these values are defined under the mobility section. Then this is the configuration of your 5G network. So like AMF IP, whatever your which component which IP you are going to assign. So all this configuration you can do with this SIM file. So then this is the your management of network interface where node 1 is defined. So then connection establishment between RAN and core elements like AMF, UPF and all these. So here is the first screenshot is shown like ng setup request and ng setup response. So this is the NGC packets coming from the radio side to the core side. So this is the signaling protocol. So signaling happens over the N2 interface. So these all packets are coming to the NGP is going towards the AMF over the N2 interface. And the AMF is responsible for signaling interaction. Then after signaling establishment, connection establishment between RAN core element, then after successful configuration, the connection establishment between the RAN and the core network element UPF. So once they got connected, then they will create a session over the N3 interface to the UPF. So all the user related data, whatever user is going to do the activity is coming to the GTP protocol. So it is showing it as a GTP protocol, and then there is ESP is mentioned because the security things are enabled in this thing. Elsewise, it will show the which protocol messages are traveling to the GTP. So these are the log files where you can check in the subsystem. Like there is a log directory as we discussed yesterday. There for particular component you can debug the logs and can check whether this radio and core network got connected successfully or not. So it will print it the log like GNB N2 accepted or not, or rejected, or what is the reason for rejection. So all this functionality it will show here. All this log debugging you can debug from here. So then verification of successful connection establishment between core and radio network access. Then it will show like these are the UPF packets. Once the connection establishment after this U is going to connect with the core network. So all user related data comes to the user plane function. So it will show like for which particular type of connectivity it has requested the packet and what are the IP address is going to assign for the user plane. So there are IE elements in the message tracing, like information elements are there. So information elements are structured data units used in 5G signaling message. Capturing and analyzing these elements with Wireshark/Tshark. So providing valuable input into message exchanges. So common 5G protocol and key elements are there are three types of common protocols used in 5G network subsystem like NJP, which is happening between the core network and the radio access network for the connectivity of both the core and radio access network control messages like end-to-end interface. Then GTP is the another protocol which are used by the core network also and the radio network also over the N3 interface where all your QoS flow and the sequence number, tunnel identifier, all these values comes into the GTP messages. Then there is a PFCP protocol. So PFCP is for packet data routing. Then FAR is there, BAR is there, backward action rules, forwarding action rules, session establishment. These type of works is done with the PFCP protocol. So this is also the common protocol over the N4 interface inside both the network component in the core also and in the RAN also. Then this is the example we have given the command example. So you can capture the packet of by filtering it out. Like here we are capturing the N2 messages. So the standard port of this AMF SCTP is 38412 for the AMF. So you can capture with the port number. This is the command like tsark is the utility which is going to capture the packet. Then I for interface. So any it marked as it will capture all the packets of the all the interface. Then hyphen F is the filter. Then which type of filter we are going to use? We have used as a port. Which port we have to connect? And then after -5 you can give the protocol name, and then hyphen O means which name what you want to name for the output file. So these are some more example of.
So these commands needs to be run on 5G core.
Yes, sir. 5G core you can if you want to debug your system like you are connecting your radio with the core network and it is not connecting, so you can debug with these commands. Like they will give you the logs. So by these logs you can understand what is the problem in the both the network. Like it can be configuration problem and it can be compatibility problem. Whatever type of problem you can capture with those tools. These are the tools like you can find.
Okay. But
Or
these
Wireshark.
needs to be core itself.
Yeah, inside the core you can run it. Inside the radio also you can run it.
Inside the
But
radio also.
inside the radio also TCP you are doing right. TCP is the utility. So tsark is the simple utility to that. If tsark command is available to any system, so you can do it by the tsark also.
Okay, thank you, thank you.
Like you are using Wireshark on your laptop. So this is similarly for the Linux we are using tsark.
So
So these are
it is not like for Windows, like if we are okay, thank you, sir.
so these are some more commands which are giving this protocol and all these packet capturing. So then two three commands are also there. How to filter a message? So filtering message is crucial to focus on relevant traffic like tsark and ysark offer flexible filtering option. So NJP message you can filter out with the NJP protocol. Then GTP message you can filter out it with the GTP. PFCP is there is a flag called PFCP. Then NAS signal is can be filtered out with the NAS minus 5Gs. This is the filter name. So below are some example like NJP. And in if you will filter it out as a NJP, it will give you all the logs of NJP protocols. If you want to filter out particular message, then you can type NJP dot that message which type of message it is like initial message is there or authentication request is there. So you can type similarly message, so it will filter out the single message according to that. Then there some other messages are there. NJP.pdu session resource setup request. Then which host you want to do with that, like a particular host interface you want to particular IP interface packets you want to capture, so you can capture according to that filters or from which IP it is coming. So from to whatever you want to give, you can give in this particular thing. So similarly, you can use these things in the Wireshark also. So this display filter as already we have discussed yesterday. So for PFCP IP address of the machine, you can filter out it in the Wireshark GUI also. And there is the QS and security is there 5G core security. So 5G core network introduce advanced security mechanism to protect network communication, user authentication, and data exchange across different network domains. The security framework is structured into multiple security domains to ensure comprehensive protection against potential threats. So this is the common architecture where host host environment and mobility environment use SIM 3GPP network, non-X network. All these are the architecture is showing here. So this is the reference architecture for that. Then 5GC core security framework, key domains and features. So security domain like network access security, NAS security is there, then NDS is there, network domain security is there. So network access security, secure UE authentication and access for 3GPP and non-3GPP networks. Then network domain security, secure signaling and user plane data exchange. Then user domain security, secure UE access controls. So these are the different type of security mechanism provided in the 5G core subsystem. So then what is the key 5G security features like increase home control, prevent MC interception by verifying device location during roaming. Then unified authentication is there. Common authentication for 3GPP and non-3GPP access, such as like if you are coming from the Wi-Fi, then also it can be done. Then there is a function called as security anchoring function. So SIF is a function name. Enable re-authentication across network without full authentication. Then subscriber privacy is there. So uses SUPI instead of MC. In the 5G, if you see, it will send a SUPI or it will send a SUKI value, concealed value, to prevent the identity exposure. So security and entities in the 5G core subsystem are there like AOSF you have deployed there, authentication server function. Then multiple type of other security functions are there like authentication, credential repository and processing function you can implement. Then subscription and identifier deconcealing function you can implement. Then safe security anchoring function you can implement. So these are the different type of security entities can be deployed in the 5G network. Then this is the sample Wireshark capture of initial message with the SUKI value. Like if you see in the packet, it will show as a SUKI value. So there is the some authentication vector is coming like 5G HE AK value is there. So AK is the 5G AK is the algorithm to authenticate the user related data. So some authentication vector like AUTN is there, XRX star is there, KUSF is there. All these are the authentication vectors comes in the picture. So these are the some HTTP2 messages which are giving the same type of authentication messages. So these all you can use as a reference. So all the discovery and all this can be shown on the WASL. So this is the mechanism where you can filter out your packets like NJP, pipe, HTTP2 to if you want to see the internal core communication also on the WASL. And then there is the 5G RAN security is there. So user plan integrated and ensure both integrated and confidentiality protection. So in the 5G subsystem, we are using two type of scheme, one for integrative, one for confidentiality, or one you can say it as a one for safety. So two type of protocol are used for the data protection. All these are having three versions like version 0 where they are not securing their packets into by the help of these key values. So there is three versions of there like NEA0, NEA1 and NEA2. So these are the encryption protocol, and then NIA0, NIA1, and NIA2 are for the integrity protocol. So all these are the mechanism are used in the 5G RAN security. So there are some other things are also like CUD security checks are there, DTLS and IPsec checks are there, then certificate and software securities are there, PDCP counter check is there, and then HTTP inspection is there. So you, if you have any doubt regarding this, you can ask any question, or we can move forward to the next sessions. Naveen sir, hello.
जी.
हाँ, आगे फॉरवर्ड करें या
हाँ नवज्योत
कोई और कोई और क्वेश्चन है, आगे फॉरवर्ड करें?
यस नवज्योति.
मैं पूछ रहा हूँ कोई और क्वेश्चन है या नेक्स्ट सेशन की तरफ बढ़े? इसमें कोई क्वेश्चन हो तो पूछ लीजिए.
Sir, any questions there you can ask? Then we will go for the IMS.
Sir, do we have the hands on this network security on RAN structure in the last 5 to 6 times?
Can you repeat again, madam?
Sir, do we have hands-on session on network security on RAN in the last 5 to 6 p.m.?
I need to check schedule.
No, in 5 to 6 there is another session, AIML and IoT.
Okay.
This network security related packets can be sent to you. Like we will capture the packets and can send you. It will show all the protocols. We can mark those packets.
And you can also take the capture from your radio.
Okay, sir, can you explain that? How can we capture that, like the commands, and we just want to see over our system itself. Take
Take
the
the
TCP
TCP.
then.
Uh, Sir, we will help you out. I mean, we will directly connect you, I mean, remotely, and show you how it can be taken from your system. Maybe that is the only solution I can suggest you right now, because if you are, I think you are not able to see that logs and all, no. So that we will do it from remotely, and we will help you out.
Yes, that is actually we want to see the logs, the HTTP2 and NGAP. We are not able to get both of them in the Wireshark itself.
Yeah, fine, fine. We will help you out. There will take it remotely to your system, and we will help you out. I think maybe after this section, I mean today's or tomorrow session, we will be free for any queries and regarding hands-on training. We can directly connect you to and help you out for any problems. Okay, sir.
Also, Sunil, share your and Naveen Gupta's number in the public chat so that they must contact you guys. Okay.
Yeah, that is there. That is there. Even we shared that support team's number also. And at any time you can contact after the session because we will note your queries here also. So the support team is taking care of small issues like yesterday you talk about this firewall issue that is taking care today. So that way we will help you out.
Oh, thank you, sir. Sir, the link to the videos we are not able to get. I think you have
So
mailed it to.
that is under TCL only. They will provide you a day based day. I will ask them to do it again, sir.
I got the message from this WhatsApp message. Okay, so
Yeah.
they have made.
श्रीकांत जी,
Okay.
हम ये कैसे भेज सकते हैं सारे लोगों को डेली रिकॉर्डिंग्स? आप प्लीज उसका प्लान कर लीजिए उसी ग्रुप में.
So you can share a link after uploading.
That is the only solution, and TCL is doing that. I think maybe they are also busy with this training session.
Yes, day one link already shared on mail. Please check. Hello.
हाँ, सोएब जी आपकी आवाज आ रही
ये,
है.
वो जो
That
मीटिंग
is
लिंक है ना
already shared, right?
ऑलरेडी शेयर्ड.
Okay.
Fine, fine. Anyone is able not able to open the link or something, you can text here also. We will help you out for that. Okay. Now, Jyoti sir, you can continue.
So now we are going move forward to our IMS sessions. So as yesterday we already discovered our all IMS related data, like SIP messages we already have seen on the IMS QS also we have already seen. So we will discuss in the brief about the IMS. So what actually IMS is? IMS is IP Multimedia Subsystem is a standard architecture framework that facilitates the delivery of rich multimedia services like voice, video, messaging over the IP network, including voice over NR. So we are calling it as a VNR. So with the help of 5G network, with the help of 5G core and radio, we were able to implement the VNR functionality within the IMS. So that's why it is called as a VNR. So voice over new radio. Then there is a login screen is there. So how you can configure IMS. IMS is already deployed in all the labs. So with the help of this your credential, you can log in with the user and password like admin123. So then you can also create, update, delete any extensions, let trunks, like different features from the GUI. So what you need to do is you need to go to web browser, then HTTP or HTTPS, and then your IP address manager. Manager is our GUI software. So then a new window will open up like the window shown in the screenshot. Then you need to click on the settings. In the settings, you will find out this type of menu. Then you can filter out that menu. By Control F, you can go to the phone directory. So there will be phone menu. So you need to go to phone menu. After going to phone menu, then there is the creation of a function. Like you will get this type of screen. Click on the actions. So here create actions and delete actions and erase actions and factory reset. All these are functions you can get from here. So in the if you will go to the create actions, and it will ask you which type of actions you are going to create, whether it is for voltage, VIP, or VNR. So from extension to extension you can create here. So for 5G you need to select as a VNR. Then from how many extensions you want to create, like 5 users you want to create, 10 users you want to create, you can give it into a series, or if you want to create single, then you can give it is like a 1001 to 1001. So it will create a single. So then this type of value will come here. So once this extension got created, you can update the values accordingly. So like to create to write the value whatever is written in the SIM cards, like MC value, K value, OPC value, which type of value it is, OP or OPC, you can update from the this particular menu. Set reset MC, K value, OPC value. So like here you need to select the extension, then you need to write the which MC this extension correspond to, so it can map this mobile number to the particular MC value. Then their K value and OPC value, you can write it down here and configure your extension accordingly. As well as GUI, we are having this command line interface also for that. So there are some small commands, so you can type those commands and can configure your extension accordingly in the system to that also. Then there is some another menus are there. So class of services, we are talking about QS, quality of services. So you need to configure which extension is allowed to use which type of services. So this is the screenshot of there. So there are total two type of class of services are there. One is for outbound post, one is for inbound post. Whatever incoming it can get, whatever outgoing it can do. So all these can be handled by the class of services is already implemented in that. So you can configure according to your need. So like here, it has selected a user 201. So these are the some screenshots. So we can try it here out and we can do a live session on that. So how to create a users.
Anupam, can you please give the sharing rights to me so I can do the presentation for the how to create the extension?
Done. It's done, Naveen. नवीन जी दे दिया आपको.
Just a second. So how to create the extension?
My screen is visible to all.
Yes, yes.
Okay. Then how to create the extensions on the IMS. So this is the IP slash manager slash. It is the URL to open the web GUI for the IMS. Put the username and the password and the captcha and do the login. The dashboard will appear like this, and then go to the settings and search here via Control F phone. You can see here how many extensions we have created. If you want to create another extension, go to the action and do the create extension. Select the type, range. If you want to create more than one extension, then you can do the range. If not, only you want to create only one extension, then mention the extension number here and make submit. You can see the extension is created. Then put the K values and OPC values. You can search from the action bar. Put the NC. K value the 32-bit value and OPC value the 32-bit value. Whatever you want to do. And make submit. You can also search from the search bar also. Here you can see the extension is created and these credentials also submitted. Then for the class of service, one is inbound cost and one is outbound cost. Mode should be there and the class of services you can select here for the calling purposes. You can see here again give the extension to the dialing rights. Only for intercom, just put on and submit. That's how you create the extension on the IMS. Navjyoti, you can continue. Shirkan sir, give sharing rights to Navjyoti.
Yes, given right to Najut.
Thank you, sir.
Hello, as Naveen sir has already shown you how to create the extension from the GUI. So similarly from the CLI also you can create the extension similarly like. So I will show you the command reference only. So you need to go to the CLI admin. This is our command line utility. So there you need to type command extension. Then if you will type and enter, it will give you command suggestion like what type of activity you want to do with the this particular command. Like you can do the extension creation, then you can read that extension property, update or delete. So similarly, like if you will type here extension create, then you need to type any extension number or any mobile number. Like if you want to create a mobile number 9800012345 is your mobile number, then you need, whenever you will print enter, then it will give you some options like which type of extension you want to create. So here you can create your phone type extension, UNR type or voltage type, whatever type of extension you want to create, you can create from the CLI also. All these commands are available on the CLI and GUI both. So all these user manual will be provided to the lab. So now we will go move forward to the live calling on the IMS. So we will make a VNR call and we will show you how you can debug that call also. So similarly like rpkb-nd is the utility. So we have run it in the server. We are going to connect to the Wireshark.
Hello.
Yes, sir.
Sir, what system are you connecting to right now?
I am connecting my core network to debug these messages. So I can show you how the process is happening in the VNR call.
Your core is at 221.
Yeah, this is my local core in the office network. So this is 7.221. I have set it up.
Okay, okay. I was
Yeah.
confused with that. This IP. Okay, thank you.
And this is my core system. So in our system there is a utility called SNGraph. So this is a one utility MobaXterm I am using to connect my core network. So also you can use Putty is provided to in the lab. So Putty is also one another software you can connect your core system with this also. So similarly you can connect with from here also. So one you can debug from the Wireshark. Another one you can debug from the command line utility there called as one. This is a Wireshark is connected to the core network. For IMS there is a protocol called SIP. Also if you want to debug it from the command line, so there is a utility in the system already provided called SNGraph. This is equivalent to the Wireshark. So it will also show you here packet captures. In this also if you will press the F7 key, so you will can filter out your messages like registration type message you want to see, invite type message or subscription type message you want to see, notify option, whatever you want to filter it out, you can filter it out here.
Sir,
Yes sir.
can you please go a bit slow because we are lost? Like we open the Wireshark, now you are at this Putty, I suppose.
Yeah, both I am showing simultaneously because whenever I will make a call, it will capture to the both, then I will explain in the both.
Now, how did we land on this screen, this current mode online array?
This current one, you just log into your core network, right?
Yeah, yeah, this command S and grep. Okay.
SNGREP. SNGrep is the command.
Okay. So we have to run it
When
on.
you
Okay.
you enter that command, then press the enter. Then
You
with the
don't have.
help of uh, then if you want to filter out some packets or you want to see all the packets, if you want to filter out some packets, you can press F7 key. With the F7, you will go to this filter options, right? In this, you can filter out any type of packets you want to filter it out. Yeah,
F7.
yeah, F7.
Okay. So how do we remove the star?
Just to go to that particular menu by the up down arrow key
Okay.
and press the space button.
Space bar. Okay.
Yeah, got it right.
Yeah, got it. Got it. Thank you, sir.
Yeah, how many filter you want to keep here? You can keep and then press enter. So it will filter out all the packets according to that. Like, yeah, let me open the mobiles also here on the visor. So you will able to. So here I have connected two mobile phones. So first is this one. These two mobile phones I have connected. As of now, they are in flight mode. So as soon as I will remove this flight mode, so it will connect to the network and then it will initiate a registration request to the IMS. So once we will go to BIOS-ARC, so here we see that over the GTP protocol, because this is a user plane data, right? So it starts over the GTP, then internal core communication is happens on the SIP protocol. So all these packet will show into the BIOS-ARC also.
फोन देखिए किधर से उसी के भाई साहब के पास ने व्यू कितना
Here,
चलो एयरफ्लो
Any doubts, sir?
sir, we are trying. Just hold on, please.
Okay.
Okay, sir, please go on. We'll do it later.
So I have connected one UE to the core network. So let me show you the value. Like this UE is having MC value 00101, then at the end it is having 207, right? So this WireShark message I got for registration request in the WireShark. If you go to this option and check, so there is a registration request from the 001019876543207. So this packet comes from the mobile for the registration request. In the WireShark, with the help of this SIP filter, you can capture like that. On the command line, where we go, so there is this registration message is there first, then subscription message is there. First registration message. So this is the registration message comes from the UE IP and port to the PCSF IP and port. So this is the registration message. So when you open this message, this will be the similar message shown in the WireShark. So these are the two different type of utility. By with the help of that, you can debug your packets. So this is the initial packet sent from the UE to the PCSF. If you go to the BIOS-ARC also, you will find the same headers. Like I will show you. These are the headers sent by the UE. Like via header is there, then max forward, then proxy, contact to from. So these all same will show here also. Like via max forward, proxy, contact to from, call ID, CSEC, expire, allow supported authorization, security, and content length. Right, sir? Any doubt in that? Shall I move forward? If no doubt is there. Okay. So as soon as this register packet will come to the PCSF, PCSF will send 100 time back to the UE, so UE will not attempt re-registration again. After that, this PCSF will send this message to the ICCF to interrogate this UE is valid or not. ICCF also will send 100 rank to the UE. Then ICSF will forward this message to the final serving CSCF, that is called as a SCSF, this register message. Then SCSF will check whether this message is having authorization or not. So how it is checking? In the authorization header, there is a tag called response. If response equal to value is null, then it will ask for the authorization. If this response is having any value, then it will take decision whether it is a valid UE or not.
Excuse me, sir.
So in the first initial registration packet, like their response is null, right? So UE has not sent any response. So what SCSF will do? SCSF will send some value to the UE back with the 401 unauthorized. So it will send a nonce value.
Excuse me, sir.
Yes, sir.
Sir, we are able to see the messages from this when we turn on and off airplane mode. So, how can we land on this page? Like, please, yeah, we are confused with
This
the process. Yes, in this
okay,
on this.
like
How do you
like
navigate over there? I'm not able to see this over here in my screen.
this register packet. Now all the packets are showing. Or
It
you
is
want to from
subscribe, it's notify, 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 something like that. Yes.
So we are in this page.
We are on this page. We have a subscribe
yeah
message, one register message, five notify
yeah.
messages, and again register and subscribe. Yes.
So first message is like register message. Notify is going from the IMS ID if any UE got connected and if got disconnected and notification and all these are going to happen. These are more packets are coming on. So our initial packet is register packet only, right?
Yes.
So once move cursor to the register packet, then press the enter key. So it will open the all the registration process there.
Okay. Yes, we got
Once
that.
you press enter key, you will come here on this picture, right?
Yeah. It is showing. Yes, it is showing arrows. Your is like okay Q. Yeah. Instead of Qs,
Yeah,
it is arrows.
yeah, arrow. So now you can see particular packet. Like this is the entire call flow from and to where this packet have traveled. Like first is 5060 is our PCSF port. So first packet land to the 5060 only. Then PCSF response back and send this packet to the ICSF. Then next packet is going to the 4060, right? Then similarly next packet will go to the SCSF. So this port you can see here is the 6060.
How do you open this interface, sir?
Uh, Select and means move your cursor to any packet like register packet is there, right? By the up and down arrow key, you can move over to the packets like this.
Yeah, I can see that it is moving. Yes.
Yeah. So any packet you want to select, like initial registration packet you want to select. So take your arrow to that and press enter.
Let's enter only. Okay.
Yeah, enter only. If you want to go
Yeah.
back, press the escape key, so it will go back.
Uh, got it, sir. Thank you, sir.
Got it? So similarly,
Yeah.
this process is going to happen. First registration come to the PCSF, then it will go to the ICSF for interrogation whether it is a valid UE or not. ICSF will interact with HSS and check whether this UE exists or not. Then it will forward this packet to the serving CSF, what is associated with this particular MC, right? Once this packet will reach to the SCSF, it will check whether it has a response header or not. If response header is there, it will check whether it is a null value or some response is there. If response, like in our packet, response is null, right? If response is null, it will send the UE to it will send a packet to UE for the authorization. So it will send a 401 unauthorized packet to the UE, like you are not authorized yet, and it will send some values. So values will be one will be a realm value, whatever your domain will be created on basis on the MNC value. Then it will create a nonce based on some random value and AUTN keys. Then it will define the algorithm, which algorithm you need to select to create the response. Then CK and IK value it will send. ciphering key and integrity key. And then which type of protocol has to use for the authentication? Like there are two type of protocol in the IMS. One is auth, one is auth internal, auth IM.
Hello.
Yes, sir.
Sir, I have a problem in the screen itself. Like we are not able to see the whole process. We are able to see the IP address of the phone, then of this 5G core 5060 IP 5060 port, then 52590 port. Then it is hidden by this the layout is not right. Can I share the
That,
screenshot?
that can be fixed over the one-to-one call only, sir. This is a live session, so
Okay, thank
means
you.
as of now I can't take access that system and cannot
Okay,
include
thank
myself
you.
to that activity, right? So that support team will support you in that. So whatever issue will be there, we can rectify that.
Okay, thank you,
So
sir.
yeah, so it will send some parameter values. Based on that, you have to create their response. So this which type of authentication it has to use? Integrity key, ciphering key, then algorithm it will tell, and then nonce value it will send based on some random values and based on the timings of the system. Then this message will go back to the ICSF. ICSF simply forward it to the PCSF. Once this message will reach back to the PCSF, PCSF will what it will do? It will take the seek and IK value to themselves, create a response, store within the PCSF, and rest value in the www authenticate packet it will send to the UE. So for the UE it will send a nonce value, algorithm, and which authentication method it has to use for authentication or auth internal. There are two methods, right? Based on these parameters, you will create a response header in authorization tag, and it will send back to the system. So now you has created a response. In this next packet, you will see same nonce value it will send back to the core. It will send its username, then renum value, then URI, nouns. Then it will create a response and attach it with the registration message again. Also, it will tell which same algorithm it has used or some other algorithm it has used. Same authentication protocol is used or not. So if this response match with the response created by the PCSF based on the previous packet, it will give the U 200 OK. Or if this response doesn't match, it will give you the UE like a bad credential or whatever the situation will happen according to that. Like user doesn't exist or bad credential, this type of value it will respond back to the UE. So once UE is getting 200 OK, means it is connected to the IMS network. Then IMS will send you a subscription like this is your mobile number. That is the MC value, that is 15 digit value. Or then usually you are getting 10 digit mobile number, right? Here we are using 3-digit mobile number. So IMS server will notify you that this number is associated with your subscription. So this information passed back to the UE. Notification will go to the UE back, and then UE will respond with the 200 OK that I got this notification, and it will tell its IP and port whatever is required for communication further. So this is the registration process happening between the core network and the UE, this IMS network and the UE. So now I will connect one another UE also, and we will create a VNR poll using this particular numbers. So now I have created one more user. So that number is 3222. Previous number is 207 assigned to the UE. So from this number we can dial the number like 207. This is the registration process till now. Now we are going to create a VNR poll. So we will dial the UE subscription number just simply. Wait a second. Let me check. As soon as I will dial this number, so on the other screen, it will show that an incoming call is coming from the 3222. You can answer this call and your communication will start. So this is the process of this VNR call. Whenever you are making a call, there is the invite header is there. Like in previous, there is a registration header that indicates that you want to register themselves with the network. If you are making a call, that means you are inviting someone to talk to you. So for that particular thing, there is a invite header. So this invite header carries the information like who is the originating header, like from whom he want to talk to, like 207 I have dialed. So all these information is carried forward in this invite header. Then there is some codec and all negotiation is happening based on that which codec they are supporting, like AMRW is the codec that is going to support in the UEs. So whichever codec it is supporting, it will share it with the IMS network. So based on that, this invite will go to the secondary UE. Then secondary UE will respond it back with the whenever the call is ringing, it will give you 183 session in progress. Once the call is answered, it will give you 200 okay, like this session is established. And then after that, there will be acknowledgement from the initiator that the session is established or not. And after that, there will be the RTP flow. So it will show you the RTP flow, like two UIs IPs are there. One UIP is this one and another UIP is this one, and they are talking to each other over this codec. Any doubts, sir?
Hello.
Yes, sir. Any doubts?
Yes, sir. How have you opened this call flow? We have connected both our devices and we are in call and we are not able to see the screen.
Audio.
Yeah, this RTP you are not able to see it. You can press the F3 button.
F3, okay. F3, okay.
Once you press the F3, it will show you RTP stream also.
F5.
F3.
First
F5 will
F,
erase.
then after F3?
F3, then you need to go to the, like, let me tell you. This is the invite packet you are seeing, right?
Yeah.
Enter in this packets.
In invite packet, okay.
Entered.
Yeah, got it.
Press the F3
F3.
and go
Yeah.
down.
Yeah, got it. It is showing, yes, got it.
It is showing, right?
Yeah, got it. Thank you, sir. F3
Okay, sir.
in the invite, okay.
Anybody else is having any other doubt?
लेकिन going to RTP on I want to get actually end-to-end encrypted in the one machine. So
So this was our process live training on IMS with user creation and behavior coding. So we have seen user creation from the GUI. From the CLI also you can create the same type of users. And we have made a beginner calling after registering our user to the call network.
sir,
Yes, sir.
In the SN grep, is there any possibility that we can track this audio packages also?
Can you repeat again? What you want to track?
uh, to capture the audio, like what the call is in progress. Is there any chance that we can get those packets also?
These are the RTPs, the audio packets only, sir.
So it is just showing the transfer between the what the packages can we capture, like in Wireshark. Uh,
Yeah, yeah, you can capture from here. You can open same stream in the same packet in the Visa. Like if you go back, na. If you want to
yeah,
store these packets, so just select
yeah,
this packet, and
yes,
then there is option F2 is there. F2, if
F2,
you need to press, when you press the F2,
yeah.
it will ask you to save the packets in the PCAP form. So any name you
Okay,
will give, store this packet and take it out from the server, and you can listen it in the Visa. Because this
okay.
command line don't have any interface to listen it out, right?
Sir, is there any strong utility there? Okay, sir, I got the answer. Thank you, sir.
Got the answer. So any other doubt is there? So otherwise we can move forward to our next session. सुनील सर कोई डाउट हो तो एक बार पूछ लो नहीं तो फिर नेक्स्ट सेशन पे आगे बढ़ते हैं
Yeah, I think you can continue with the news. I mean, next session. If anything, they will text us in the public chat. Then let's see.
श्योर सर
Please continue.
so we are moving forward to our next session that is about configuring of 5G radio G node base. So accessing the G node base through the IP address. So every network device is having its own IP address. So you can access their CLI or GUI options through that particular IP address, connected through SSL, or you can connect it through the web services like HTTP. You can connect it. So like here we have logged into our radio. It is showing a screen. So there is the IP address of radio like 192.168.1.222. We have assigned our local radio whatever we are having here. So I will show you live also between the this, like this is the our IP address. So I will open it in the browser. So in the same page we can configure this radio like 8.1.2.2.122 colon 8080. So 8.1.122 is the IP address of the radio, and 8080 is the port where you can access the GUI of that particular radio. So once you enter, you will go to this screen. Same shown in the presentation. So you will go to the same screen like this. Then you have need to enter your username and password. Username is given as a resonance and password is also a resonance. So we will log in with the same thing, resonance, and then password will be resonance. If I will show you the password. So once you click on the submit button, it will log in to the GNodeB home screen. So here it will show you all antenna uplink down, whatever processes are running there, and program links, remote.
Sir, this IP is not accessible from this browser. Our
No, no. For your radio, there will be another IP address of Gnode, right? This is
Yeah,
my
we have IP address of the radio. It is 28.15 instead of 8.122.
okay. Okay.
Is there a difference in the port, like the
Sir,
deployment
sir,
of it?
sir, there are two versions are supplied. I think you are having that version one radio. So that we will take it the next session. Now he's Navjoti is taking the version two radio. Okay.
But it's okay.
Actually, sir, we are having two different types of radio. Like first, we have initiated created version one. So some places it is applied version one. Then we have created version two over that version one. So some places it is version two. So this is for version two. Version one also will include in this same session. We'll show you how
Okay.
to configure.
Our system is of version 2. Okay, thank you, sir.
But your system is on version one, I think. This is version two session is
Okay,
running
this
currently.
is ours is of.
So like this, we have logged into our Vinode way. So this will be the home screen comes. Then according to our PPT, we need to go to network configuration. We want to configure the network. I think somebody is in traveling and okay, move forward. So in the next slide, it is showing first what we need to do. We need to configure our network according to our core network or other network subsystem, right? To interact with each other. So default, uh, if we want to change the IP address, this will be the screen. On the home screen, there is a network configuration option. So like I will show you. There is a network configuration icon. You need to click on the network configuration. Here is the interface name. Which type of IP you want to assign it, automatic or static IP. You can assign from here. Your IP address, whatever IP address you want to allocate. Like if your core network is 192.168.15.10/24. So in the 15 series, you assign any IP address in the Gnode here, like 192.168.15.100 or 15.101, whatever the free IP address you can assign here. Then your core network subnet should be reside here. Then your gateway, through that it has to interact with the other network. If it has to interact, you need a gateway. Then you define a gateway here. Then whatever domain name is required to assign here, like from where it has to resolve its DNS related queries. So core server IP you can define here. So core server is already configured with the DNS. So all these configuration you need to do and need to update and network apply. Click on the network apply and update. You can update like that and can reboot your system. So it will be configured on the new IP address. So these are the network parameter related configuration. So for this particular parameter, we need to be careful because these all are. This is the mechanism by which you can access your node. If you have entered IP address you forgot, then you need to find it out. To change the IP address of Gnode, step 2, after changing the IP, click on the configuration save to apply changes. So after here you change your IP address, then you need to save your configuration. So on the next reboot, it will not flush it out. So you need to click on this switch icon is there, then configuration save icon is there. So you need to click on configuration, then it will ask you for that you really want to save either run init config. So then you need to press OK. So it will save all the configuration here. Once your network, once your Gnode comes into the network, then you need to connect it with the core network. So to connect it with the core network, you need to go to this management element configuration. In management element configuration, there is a CUCP function. Wait a second. There is a CUCP function. Then here, because radio communication and core communication is happening over the N2 interface, so you need to go to this NGC N2 interface. Here for the remote, you need to define the IP address of core. Like our core is 7.221. You were earlier asking about what is 7.221. So this is our 5G core net server IP address. So you need to define here that which core it has to connect with. And then same process, you need to update configuration, then save configuration. Then you need to configure the frequencies of the NR cell functionality of this particular thing. So for that you need to go to the DU function. Under the DU function, NR cell is there. You need to click on that. Here you can define your frequency. Downlink, uplink frequency you can define here. SSB, ARFC you can define here. Then SSB periodic timeout, and there are some parameters are there. So you need to define all these parameters according to that. And then there is PLMN list, like which PLMN it has to support, like 00101, whatever PLMN you are going to define here, it will show here. So this is the GNODB configuration parameters. Configuration of PLMN slicing. So like this you can create your which slice you need to enable in the GNODB side. Like here we have enabled 1, 2, 3, 3 slice. Main PLMN, whatever it is, second PLMN, third PLMN, you can configure like that. So here is the SST slicing values are there, which it will support. So based on configuration, it can be allocated to the user equipment. So this is under the vendor config, there will be option vendor common. In the vendor config, you need to go to option vendor common, and here you can define all your elements. Then after all this configuration, you need to go to this save configuration, apply that configuration, and you need to reboot your system. So once you will login it back, this will come as it. So it will run its all services, manager, SRN, OBS, all the services it will run, and if it will connect, it will successfully able to connect with the core network, then it will make the cell app in the green color. So if any alarm is there, it will show it's under the alarm. So you can make it GNODB restart also. So this is all about how you can connect your GNODB with the core network. So what you need to take in the mind. So there are few parameters are there. One is your IP address should be in the range of core network IP address. Means both are should be accessible with each other, so they can communicate with each other. Second thing, your PLMN ID should be configured properly within the core network, also within the GNODB also. Third thing is your tracking area code comes into the picture. So tracking area code configuration should be the same in the GNODB also and in the core network also. These are the three parameters: MNC, MCC, and tracking area values, which are commonly shared with the core network and the GNODB. So based on these they are going to communicate with each other. So you can take the help from the Wireshark also, and can take the help from the core log or Gnode log also to debug your problems if you are facing any problem while connecting Gnode with the core network. So these all are the configuration about the version 2 radio. Now we will move forward to the version 1 radio. Naveen, Sunil sir,
Please, yeah, please, sir, tell me.
so you can start your version 1 radio
Yeah,
configuration.
version 1. Okay, okay, okay.
Version
Can you
2 is
please give the
this
मेरे को
one.
देंगे.
So shall I stop?
Yeah, yeah, please, you can, sir. You can close. Sir, can you give the rights to Naveen? Shrikant sir, Shavi sir, give the rights to Naveen.
Done.
Yes, given. Please check.
Rajavan sir, are you there?
Yes, sir. Yes, sir.
Hello, Rajavan sir.
Yes, sir. Can you
Your
able to
voice
hear
is
me?
not coming.
Now?
Rajavan sir. Yes, yes, right now coming.
Okay, okay. Sir.
You can take the session.
Here we can see the first initial bring up procedure. We have to connect that 48 volt DC power to the G node B. Then we have to connect that Ethernet cable. There are two options are there. One we can connect direct power, and one more option we can connect with the PoE. Then that Ethernet cable is connected with the core network. That picture I will show you. So then that between the core and Node B will be connected. Then I'll show you how to log in that Gnode B. Just you have to install that Mobaxtrom application. Then you go to the session SSH. Here you have to write that Gnode B IP, and that username will be the root. So once you log in, you will get into this page. Next, what are the software components available in this Node B? There are OCU will have that L2 and L3 modules, and ODU having that L1, L2 software modules. That RF manager is the RF transceiver front end. Then checking the cell up status, just you have to run this command here. Watch system control status Raptor 2. So here you can see that CU also and DA also both are running. So the cell is up now. So you can check the cell status by login that SSH. By using SSH, you can run this command and you can check the cell status as well. Next part is that EMS and GNodeB configuration. Go to config. Here you can see, here you can assign that eNodeB IP address, what is the AMF IP address, and what is the PLM1, MCC and MMC, and what is the slice type is selected. This is the ST value, this is the SST, and this is the SD value, and the GNodeB ID, and what is the current MIMO configuration. You can do 2x2, or in future you can upgrade up to 4x4. This is the cell ID we have to configure, and the tracking area code, then PCI, and what is the band we configured. You can set the band also here, and the frequency, then bandwidth. So you can configure different bandwidth, 10, 50, 20, 10, and you can check with the different bandwidth configuration, and you can check that. And the subcarrier spacing what we are using is 30, and the TX power you can see is here 20 here. This all is the GNodeB config file. And there is one more file called upgrade.
Hello.
Yeah.
So we are not able to see the GUI of our system. We have run that command watch system CTL status chapter 2.
Okay.
But the interface over here that we are showing on the browser, we are not able to access that interface.
No, that is only for checking the status only. If you want to access the browser, just you type that GNodeB IP colon 5000. Then you will get into this.
No, we are into the browser and we put the IP of our radio, this,
Okay.
and column 5000, and it is not showing anything. Unable to connect on the browser.
Any firewall protection is there, sir, in that?
We can think that.
Okay, so once the session is completed, I will check, sir. I will check and later.
Okay, sir.
Okay. Then you can go to the upgrade. Here you can upgrade and downgrade the new version or old version of the software here. You can do this and all. Then you can go to lockdown. Here you can download the lockdown of the GNodeB. Then you go to the base station status. Here you can see the cell status as well as UE status. How many UE attached, what is the SNR, PHR, and ULMCS, DLMCS, how many layer in downlink and uplink, what is the CQI, downlink throughput and uplink throughput, blur, all those details of the UE you can see here. For cell related status, you can see here what is the uptime since we started, and cell state is active, and the PCI is 1, as we see earlier, and the TRFCN, it should be some value. Let me check this one. And the bandwidth is 273, and downlink and uplink throughputs we can check here, and blur also, and number of UE. Here how many UEs are attached you can see, and number of flash process happened, and how many SSB sent. This all the details. And here you can see the PRB utilization statistics, and here you can see the RAJ statistics, and it's all related to RAJ. This is the explanation I have given in this feedback. If you want to change the slice, so you can go to that. Then you can change the required slice format as per our requirement. And the bandwidth change also already shown. What are the configured bandwidth? We can change a different bandwidth and we can test it. This is the management. Already explained all these modules. Then BS status also already explained. Then log collection. Once you log in this page, just type TCP dump -i any -w, then file name like anything you want, then pcap. So now I am capturing the log. Control C, I terminate the log. Then you can go here. You can see the file and you can download it. And you can verify which folder you want. You can download and you can verify that log also.
Sir, I am at the interface of system CTL and I'm not able to come out of that interface.
Give Control C. Give Control C, sir.
Control C. I got it. Thank you, sir.
Okay, sir. This is the log collection procedure. That's it, sir. Nine, sir.
Yes, Rajamohan sir.
Okay, sir. My part is over.
Anyone having any query, please ask him.
Configuration part. If any queries, we can ask. There's a small session regarding the configuration part only, so I don't think any someone is asking.
Sir, what is the location of the dump file?
Location.
Yes, sir. I have run that command TCP dump, but I'm not able to locate the file.
Your machine supports
Okay. Rajamohan sir.
Yeah. Let me show you.
I found it, sir. Found it. It is root directory.
Yeah, root directory. If you want to save in some other directory, you can put that directory name also. I'll show you
Yeah,
how.
absolutely.
Like if you want to put in some other directory like / here you put the directory name, so it will be saved in this directory what you mentioned here.
So far, though no queries, I think we can conclude this session and we can continue after 2:30.
Okay, sir. Thank you, sir. Thank you to everybody.
Thank you. Thank you.
Thank you, sir.
It's a lunch break now.
No, it's not possible. You shut down the
Next session is MEC, so that will start after the next session. Okay.
ठीक है सर, थैंक यू।
Okay, okay, yes.
Yeah, thank you.
इधर लैपटॉप
वॉइस देख लेना वॉइस नवीन कहा था इसमें रिकॉर्डिंग वॉइस ओपन
Hello, good afternoon, everybody. Uh, the current session is about MEC, that is multi-access edge computing. So first, I want to confirm I am audible. So please confirm so that we can proceed.
Yes, you are audible.
Okay, thank you. So let's talk about what is MEC first. So MEC means multi-access edge computing, refers to a network architecture that brings computational resources closer to the end user, especially to the edge of the network, such as base station or even local routers. This minimizes latency by processing data near its source. Basically, MEC provides a architecture where we process the data on the edge side that is near to the user, and the user can experience a real time information without any latency or in the real time. So this is multi-access edge computing. Basically, when we talk about the IT infrastructure, we processes the IT infrastructure like resources, memory, disk, that process to the near side device like edge device that is near to the user. So this is the basic architecture of a MEC. The services you can develop on the MEC architecture like drone and V2X services, AR, VR, gaming, drones. The developer can leverage this architecture to develop the uh, multiple applications so that user can take advantage of the real time uh, information. Suppose if we talk about the IoT, suppose there are multiple sensors and the sensor sends the data to the edge device and all the processing done at the edge level and provide the real time values so that you can see this information on the dashboard. So this is the basic MEC definition and architecture. So two main characteristics about the MEC, what is the latency reduction and bandwidth optimization. So when we talk about latency reduction, MEC reduces the delay by processing data at the edge close to where it needed, which is essential for application like autonomous vehicle or gaming. See, if we process the data near to the user, uh, definitely it will process fast as compared to the data processing at the far end side. Suppose the far end side means the processing data is done at the cloud level. So when we retrieve the information from the cloud, definitely it will take the time as per the distance. Downloading a file from a USA server and downloading a file from any Indian data center that is near to the mobile tower or the radio, definitely it will take the less time as compared to the cloud side. So that is why we are saying that there is a low latency. As much as we are closer to the edge side, much it is better than the far side. So we talk about the bandwidth optimization. So when we download any file that is near to my site, it will take the low bandwidth. And when we download the file from a far end side, definitely it will take the more bandwidth and it consumes the more data. So these two factors uh, are playing a very important role when we use MEC architecture. So by leveraging the MEC architecture, user can experience real-time information. So when we talk about OTT platform where we watch any movie in the real time, so there is no buffering when we watch the movies. Otherwise, when the server is far and side, you will see any lag when you are watching the movies. So this is the benefit of the MEC. You can develop any AI applications on the edge side also to process the data. So this is the architecture. There are two servers. One is MEC Cloud Core and other is MEC Edge Core. So let's go one by one. What are the components of the MEC Cloud Core and what are the components at the Edge Core? So let's talk about the MEC Cloud Core side. So you can see there one box that is K8S, one is control plane, one is the registry port, one is device controller, one is Apache 2 My VR app, and on the lower side there is the MEC Edge core, and the box name is HD, Docker, Cube Proxy, Varnish VR app, Calico. These are the main components of the MEC Cloud Core and MEC Edge core. So let's talk about the each component one by one. So first component is control plane. So an extended Kubernetes controller which manage edge nodes and ports metadata so that data can be targeted to a specific edge node. So first of all, let's talk about the MEC architecture. It is based on the virtualization. Basically, on a physical server, there is a virtualization layer, and over the virtualization layer, the MEC architecture works. Now, control plane is a component that is a part of a Kubernetes which manages the edge nodes. Suppose you have multiple edge sites, and the main function of this control plane is to control the edge controllers. You can say these are edge sites. Suppose you want to deploy any application, so the controller decide which edge is responsible to take the control to deploy this application. The controller decide for the specific edge because there are multiple edge sites. The next component is device controller, an extended Kubernetes controller which manages device so that the device metadata status can be synced between the edge and a cloud. As I said earlier, there are two side servers. One is Cloud Core and one is Edge Core. So the device controller keep storing the metadata of the devices so that later the both edge side and the cloud side both can be synced together. This is the main functioning of the device controller in the MVC architecture. Other component is a registry port, a WebSocket client responsible for interacting with cloud service for edge computing, like edge controllers as in Cube Edge architecture. This includes syncing cloud side resources update to the edge and reporting edge side host and device status changes to the cloud. Suppose I have deployed one application from the cloud side to the edge side. Now application is running on the edge side. So if there will be any change, the edge server will reflect the changes to the cloud side, so that the cloud side server also synced with the edge side. And this function should be controlled by the WebSocket. It is responsible uh, by the WebSocket component. It ensures that the both side servers are sync with each other. So another is a Apache to my VR app, a cloud core side port that is running and contains the VR application that will push to the edge. So this is a sample application that we have created for the 5G labs. So all the application that we will show later in this slide is stored in this container. So later how we can deploy this application we will explain. So earlier we studied or discussed the four components that are the component of a cloud core. Now let's continue with the MEC cloud edge components. So the first component is HD. It's an agent that runs on the cloud edge core and manages the containerized application. So as we have discussed earlier, the MEC architecture is built upon a virtualization layer, and the main application that is managing everything that is Kubernetes. And in the Kubernetes, there are multiple containers that host the actual application that the developer uh, build the applications by the developers. So HD is a controller part at the edge side that controls the container applications. Another is kubeproxy. We all know without networking we cannot access anything. So kubeproxy uh, is a component in the MEC architecture. Network proxy that runs on each node within the cluster, responsible for managing network rules and routing between services and their underlying ports. So it ensures the connectivity between the ports. Suppose if you want to access the web service runs on the port 80. So the port 80 should be open when you are access any specific port and any application that is using the web application. So kube proxy is responsible for this function. Okay, the next component is Calico, containerized process running on a node within a cluster that acts as a primary agent for Calico, a network plugin used to manage port-to-port communication by assigning IP address, routing traffic, and enforcing network security policies across the cluster. So we discussed the last component, that is kube proxy. The kube proxy further work with the Calico to assign the IP addresses, implementing the security policies, how to route the traffic between the ports, and how they should be communicate. So the kubeproxy and Calico both natively work each other to implement the IP addresses, routing traffic, and the security policies. So other component is Varnish VR app, edge side port that contain the VR application using caching application named Varnish, where the content has been pushed by the MEC Cloud Core ports. So this is again a container based application that we used for the 5G labs. So as we studied earlier, we talked about the data that is near to the user, but behind the scenes how the data uh, we transfer from the far end side to the edge side, That is done by the application that is named Varnish. What we do, we cache the data from the remote server or any cloud server to the edge side. So the main the function of this Varnish VR app is just to cache the data from the cloud computer or cloud machine or anything from the local side. So that is why we are saying it is low latency. Uh, so another component is the container. So container are nothing, just it's a, bundle of the application where all the dependency of the application inside a one box. Containers allow application to be packaged within all their dependency and deployed on the system, making it easier to manage and scale MEC application. So, as we discussed, it is the bundle of the application, including on the dependency under one folder, so that later, if you want to deploy the MEC application, any application on the other edge side, just to copy the container and deploy it to the another edge side component or edge side server. Cubedge. Cubedge is an open source system extending native containerized application orchestration and device management to host at the edges. It is built upon Kubernetes and provides core infrastructure support for networking, application deployment, and metadata synchronized between cloud and edge. Basically, Cubedge is an open source application that is responsible for connecting all these components that we discussed earlier, like control plane, device controller, registry port, HD, kube proxy, Calico, and the application containers. Cubase is responsible for all these components so that they can work seamlessly. You can say it's the parent of all these services and the component. So there are two servers. One is MEC Cloud Core and MEC Edge Core. The MEC server are you can say always will near to the RAN side, or so that uh, the processing of the data should be fast, and UE that is near to the RAN network can take the real time uh, data from the MEC server, that is edge server. The end devices should be anything, that may be a smartphone, that may be a IoT sensor, that may be a VR set, it may be anything. So in the end device, suppose in we talk about the sensor data sent to the edge server, that is edge core, and process on the edge side. So as we discussed earlier, the MEC architecture is based on the virtualized technology. So KVM is a component that is responsible for the virtualization layer, and over the virtualization layer, there are multiple guest machines, you can say, uh, and MEC core and the edge core. These are the virtual machines running on the virtualization layer. KVM is a kernel-based virtual machine, is a virtualization technology built into the Linux kernel. It allows to run virtual machines on a Linux system, turning it into a hypervisor. With KVM, you can run multiple isolated environment on a single physical machine. each with its own operating system and application, essentially enabling hardware virtualization. So KVM is a kernel-based virtual machine which divides the host resources into the multiple virtual machines, and the virtual machines are the isolated form. If you have allocated 2 GB memory to the one virtual machine, and you can also allocate the 4 GB memory to the other virtual machine. So basically, virtualization is a hypervisor layer between the host and the guest machines. So as we discussed now, the MEC Cloud Core and MEC Edge Core uses the virtualization platform as a core part of the virtualization process. Guest machines that are running on both MEC servers are like 5G Cloud Core, NMS, MEC Cloud Core, where on server guest machines are running MEC Edge Core. So these all are guest machines that are running on a virtual uh, architecture. 5G Cloud Core, NMS, MEC Cloud Core, and MEC Edge Core. These all are the virtual machines that are running on a virtualized environment. So this is a host server graphical interface. So you can see a virtual machine manager. So suppose you want to create a new virtual machine for any application that you want to uh, deploy. So before that you have to create one guest machine. So this is the virtual machine manager. By using this you can create a new machine for any purpose. So this is the dashboard for the virtual machine manager. You can see there are three virtual machines. One is 5G core, one is cloud core, MEC cloud core, and NMS. And you can see also a status as running for all these guest machines. You can control these guest machines by the tools that you can see here. If you want to stop, you can stop. You can restart also. Go to the file option. You can create a new virtual machine also. So KVM supports the multiple operating system. You can install Windows. You can install Linux. So this is the all we discussed about the architecture. Now we are moving to the deployment side. So what type of applications? How we code the application uh, which we can use to run the application. So this is a one application that we have developed, MEC core server, and one is MEC deployment tar. So these are the bundle of the application that you need to install on the MEC servers. So let's talk about the use cases for MEC. So there are AR VR applications that require a low latency to provide immersive user experience. MEC enables this by processing a data closer to the user. So here we will discuss about the VR application. We will deploy this VR application from the cloud side. We will cache this application to the edge server, and we will use the edge server for the application so that the VR we can use the VR to watch this application. MEC can support AR/VR application by offloading the graphic rendering task from core to edge, ensuring faster and more responsive experience. As we know, all the processing will processes at the edge side after caching to the edge server. For caching, there is a application name that is Varnish. So Varnish caching is a high-performance HTTP accelerator commonly used to speed up web application by caching the HTTP response. It is often deployed in front of web server to reduce latency and decrease the load on backend server. Integrating Varnish with containers can enhance scalability and performance. Here's an overview how you can use the Varnish caching in a containerized environment. So Varnish is an application that caches the data from the MEC cloud server and cached at the MEC edge server. So this is a screenshot of a web application, the VR application that we have opened using the cloud. Means the application is hosted currently on a MEC Cloud Core site. So when we will push to this application to the edge site, you can open this application from the MEC Edge Core IP address. So this is the internal view from the VR set. When you will click on this any video that we are showing here, the user can experience a real time uh, data from the VR set. So now moving to the further section of how we can monitor the services in a MEC server and MEC edge server. For this, let's go to the server side. So this is a host server. So you can see it's a virtualization daemon. So it means that the libvirt is a service that is responsible for managing the hypervisor layer and responsible for running the guest machine over this. So this is a command by which you can check whether this service is running or not. The service name is KVM and full command is MEC status KVM. Now, how to show how many virtual machines or the guest machines are running on this physical server? The command is so you can see there are three virtual machines running on this server. One is 5G core, second is NMS, and third is MEC Cloud Core. And the status is running. Now let's go to the MEC Cloud Core. So this is Cloud Core machine. and this is edge core machine. These both are guest machines, or you can say these are the virtual machines. So if you want to check whether your cloud core and your edge core both are currently running or not, you have to run this command. MEC status nodes. So you can see the command printed the two lines. One is about the MEC cloud core, and the another line is about the MEC edge core. So the other column is status. Status both are ready. Role, the MEC cloud core is a control plane. Age, it is running around from the last 76 days, and this is a version. And MEC edge core status ready. The role is agent. The same age is same. It is running from the last 76 days. This is the version. So here you can see the role also. The control plane means the cloud core is managing all the edge nodes as we discussed earlier. Here is only one edge node. That is why it is showing only single edge core. If you have multiple servers near to the radio network, then you can see the multiple edge servers here. Right now there is only one. That is why it is showing only one. Now, if you want to check the resources on a MEC Cloud Core, you have to run this command. So you can see the printed output is talking about the server load, how many processes are running, how many processes are sleeping, how many are stopped. So what is the server load, what is the total memory consumed, how much memory is free. So you can watch the resources by using this command. You can see a 16 GB memory is total allocated to the MEC Cloud Core. The 12 GB memory is free, and 1 GB around it is using. So these are the 346 total tasks that are running.
Hello.
Yes.
So we don't have access to root.
Hello. Yes,
We don't
please.
have, we don't have access to root. We have only support password, and super user is not working over here.
So you don't have root password.
No, we don't have that.
Sir, the support password is also the root password. So you will have to do sudo su.
You have to run this command and type the support password. You will get the root access.
Got it, sir. Thank you.
Okay, thank you. So by using this command, you can check the allocated resources, how much resources your virtual machines consuming. Suppose if you develop the application that is very resourceful, you can also increase the resources from the KVM control panel also. Further